This video is we move to the second part of this overview. So this mind map is I have reshaped is we discussed part one of this Mobject initialization. So discuss what is the Mobject and what are the one of the three of the Mobject classes called is vectored Mobject, and we will stop until this our demo, which is our basic this curve that we can draw in our this coordinated plane. So let's first go to here. I have updated this mind map. So now these are the better structure. So under our deep dive is finish instruction, introduction, and we have the overview with the three parts. We have done this preliminary. Now move to this M object. Within the M object is first is what is the M object. So if you look at the over this guide is also mentioned here. So you can treat that as either way. So M object either stands for mathematical object or Manim object. To myself is first is depending on who you are talking with. So I want to keep that as the Manim object as the simple one. And then these people may ask is what is the Manim object means. That then you can use this mathematical because the reason is I think Manim now is have the broader view and the broader the utilization is may not limited only draw some mathematical formulas. So you can treat Manim as our scientific diagramming or the animation tool. So try not to use the mathematical to limit your idea. So try to see but anyway, this is our term within the Manim. And then the Python class Mobject is the base class for all objects that should be displayed on screen. So that is the thing we need to pay attention to. I will not go to the every detail for that, but you can see here I gave you some link which is related to the here. So like is the initialization method. When we're talking about is how this M object initial the this method is better if you got time is to come to the source code. So let's come to here. So if you click my link is you will get here. That is the Manim community project, and under the Manim we have this main branch, and you can see the source code under Manim. There's a folder called M object. And this link come to this mobject.python. So try to take some effort to go through the code. Source code is also give you some more understanding about the feature of this tool. So here you can see is for the initialization or initial attribute value. So some from this code you can see first is that there's some import, and then the moving after this import, you will quickly come to this class M object, and then this we have our initial this attribute. So here is we go this within the initial we have our string called the type is called the name. This is made the render log mentioned in the name of the M object instead of its type. And then we also have this sub object. So we can see here is you can either is go through below, then this you can find those different the class that will help you, or when you write look at this source code is use this sub object, then you can come to here. So add object as a sub. So as go further, So let me see the first one. So here sub object is the least content value of the validation. So those are the sub. And here is a list of this object, and they have certain things for the initialize as are this empty part. So if I go to the initial, so let me find this one. Self is this initial. The attributes is called is empty class, so or empty list. Color is also we have this self color is also the initial like is a Manim color with this parameter is pass our color code. And then the two method mentioned here. So one method is the reset point, and another is this initial color. So and also generate point. So and if you look at mode, so for example, if you want to click this mode, so within the GitHub, the way you want to analyze the source code is double click this method, then you can see some reference here. So 116 is this one, and here is the another the use that, but here 406 is the definition part. So you can see is the reset point is actually set attribute to our empty. So let's go to here. So it's called to the numpy 0, 0 to self dimension. So that is our numpy vector. So why we can use this NP? If you go to the top, I think is we have this one. So using with this Python code is we already import numpy as NP and also generate point. So let's show you this as well. So click this, and then you can see the 417 line. So here is nothing the defined here, similar like this init color. So that means to just implement as pass because M object here is explained is that doesn't supposed to be used as an actual object. So something is to just try to define the or initialize certain the class first or method first. But how to implement that is depending on the how you code that. And there is three type of the M object come into the play. So I also put that here. So this one. So this carrier, so renderer. So is I will also put this here because if you read the code, you will quickly know is they have used this carrier graphic method to all these external third-party library to render your the pictures. How they use that is if you back to the here, money, the root, then you can see we just come from this M object. Click this renderer, then you can find this carrier renderer. And with that is you may get some more definition. So also you can see from this init. So they define the camera class, they define the file write, and a certain those method. So that is the renderer. So if you want to learn more, you can come to here. And then there's three type of this M object. First is the static, the image we call this image M object. So that is if I back to again, so M object, then come to this M object here. So oh, I saw the vector field. That is nice. So and let me search image. So you can get is get image, that is one class and the show or the save. So all those are the image, the such kind of those uh, the let me see. but we don't have that class mentioned here. So, but you may know is in the M object they can handle the image. PM object is some the specific M object. There's no the this touch base on our this guide, so we will skip that. But let's move on this VM object. That's not means vertical. That's the vectorized. So means is that is a list of the vector that used to combine consist of different points and connect through the curve. That is the famous one is this Bezier, the curve. So which I also, let me close this one. So let's go to here. So Bezier curve, I gave you this Wikipedia part is you can get is quite nice things is uh, like these are three uh, point and you have a line to connect through this connection of these 3 point. One is this P0 to P1, and you have a point move from P0 to P1. At the same time, you have a point move from P1 to P2, and you connect all these link and find the this curve to match this link. So that is the point B. You can see here is the interpolated linearly between Q0 and Q1. So that is the definition for this Bezier the curve, and the purpose for this Bezier curve is trying to help us to draw some curve doesn't have those solid part. So that is the mathematical representation, and also usually to have this real world shape that gave us a very smooth continuously curve by means of this formula. So that is the definition, and here is also mentioned by this guide is here is the textbook, but this GitHub page is not accessible. So if you come to here, is the site is changed. So I have do some the Googles, and I find is they have moved to this Bezier info -2 this repository. You need to download or maybe the clone, and then this compile, or maybe you can build yourself through this Node.js. Then this, and also you should have this LaTeX support. Then you can read this as a textbook. So I haven't opened that yet, but through this link you can find this page. What we will going to do is we will use the 8 point 1, 2, 3, 4, 5. I think is we have another one. So one is the this one is reused, and 7, 8. We will use this 8 point to come out for the Bezier this curve through the our Manim as a sample. So let's now go to the our demo. And by the way, is I have actually solved this the OS arrow. So now if you can see, I can compare using this way, and it's just going to processing this compile, and then is able to open the video now. You can see it's automatically open this one. I can play, and that is our animation. The way is I did this fix is actually is I found that may not be coming from Manim bug. Is may due to is my default app for playing the video. So I also try to play video is outside Manim, unless I change to another the media player. I think that is some issues in my Windows. So I changed this default player. Now the Manim, I think is they just read the default setting. So now they can go to the workable this player. So that is solved. So I already closed that issue in the Manim site. And then let's go to the 2.23 quickly. Is we did this like our Object demo. Actually, this build are the Basel curve. So we can see here, if we want to make this is I can see is the Basel py. I use this way. So from name import those. So class is VM object demo, and def construct self. So to make this Basel curve, we need our list of the point, and those point is actually is defined by the VM object. So that is the purpose. So first we have our plane with the number plane. So self add, let's go to plane. So we just have this one. So let's test minimum. So let me see. Dot is the Bezier, is the VM object demo. Let's try to compile to show the our coordination plan first. Yeah, you can see that is called is number plane. So it's perfect. So this is the first time we draw this number plane, but it's very useful for you. So let's see. So that is a static one. So it's coming from this part, and we use add method. So there's no video. So that is we know already. So and we can use this PQL. So now let's we know now we are working on this one. So let's continue to have the next line. So VM object equal to, I think it's you can use that. Oh no, object. They are not consider that is green. So the green is this curve line. So we will use that to draw this. And then my VM object define the points. So then this we can use this enter. Then here we didn't do this numpy load, but we already read this M object source code because Manim load this M object. M object already import numpy, so that is the prerequisite. So you don't need to do that double times. So first line, we do this line. The first point is this one, minus 2. Minus 1, that is x, y, and z is always the 0. So we now only render the 2 dimension, but keep in mind is the space is the 3 dimension. So we can use this. So we can define this. Let's render this now. So to see whether this numpy is working or not. If there's no error, then we will be perfect to continue. So that is good. So what I will do is I will have that copied. that is the 8 point. Then I will one by one. This is the minus 3. That is positive 1. And third is 0, 3 is this one. So 0, 3. And number 4 is the 1, 3. So that is the 0, 3, not a 3, 3, 1. And 1, 3. And number 5 is keep 1, 3. We use that, and then this linking to this 0, 1. So 0, 1. And then we go to this one. It should be the 4, 3, 0. And this 4 minus 2. So we don't need to verify that. Let's continue. But if we have those, we can see is my object. Actually, I can put that here. But for now, I don't have any the method to show that. Let's see if I add them. What are those points? It can be shown already. I hope so. Yeah, it's already like this shape because that is the way your VM object is drawing is use this Bezier the curve this formula behind. So now what we will do is we also want to handle for this right point. So that is another display we need to do. So but the green lines or green curve is already there. So handles equal to this one. So we will use some single line definition point. That is the red 4 points in. So those we will do this minus 3, this one. And we make our, this is one line, this is another line, 0, 3, and this line. So we have those 4. So now let's see 4 minus 3, 1, 0. You can use one line, but I prefer use multi-line. So every line just took is 1 point coordinates. That's ensure it's easier for you to do the troubleshooting. Then this 4, 3, 0. And then we done this one, and we handle the line. Line is we just wanted to connect this one, connect to this one, and this one, 4 lines. So that is through our this looping to do that. And if I put those points, it's you need to use their with stars. So let me see handles before I connect them. I should have those dots here, 1, 2, 3, 4. So that is expected. So now I also suggest you do like this way, so you know every components or every block of your code, what's their purpose. So handle lines. So these are draw some lines, and the line is sum the parameter. So my VM object dot point. So we use that as our the arguments. My object dot points. Yeah, I should use the prolong. So go to the next one. So indeed +1. So that is gradually have that. Let's go to this with blue, so that we get some different. So point is in red, so this not red, then you know what's the actual draw from here. And then we will for in the range, give a range 0 to your object points length. That is our vector rest the object, or you can treat that as a list, so they have this range or length, the property. So then we go to 2. So let's see the start, stop, and stepping. So with stepping, we use 2. So now, oh, I didn't put handle line here. So it's just calculated, but it's not showing here. So line is not defined. Handle line. Oh, this is good. So it should be the capital. And then handle line. So now the code is complete. So let's do this now. So you can see that our blue part is here. And I think it's our number plane is doesn't have our the color. Can I make our color of that here? So color equal to, maybe I put this yellow, so it just gives some idea or generate arrow. But it's no effect, so I will remove this, not take time on this video to examine that. So we render that again, so you will get the correct image Bezier, the curve. So just remember is the theory behind this VM object connecting point is they go generate a smooth curve. This smooth curve is based on this Bezier curve methodology. So try to read after the video is from those links I gave to you. And we started, so we finished this first part of this object initialization. Next part is we will discuss this square and circle and adding object to the scene. So see you in the next video. Bye for now.